And then of course we have our clock in here as well, which is this white wire. And in this case, input and out.
Crap! We forgot to put a nice white wire underneath all the thick layers of green cables like Ben Eder did it. Hello everybody, how's it going? Welcome back to the stream. It's cool, we retained some viewers from the massive weekend from the influx of my YouTube video. That's awesome, cool. Okay, so for today, it's gonna be a bit shorter stream again. Yesterday was an exception, but we made amazing progress today. So for today's stream, I want to start with just showing you what we did yesterday for those who haven't been there, and then we go from there. Okay, so let me show you where we left off yesterday. As you can see, we have finished the ALU. At least I believe we have finished it. It seems like ours is working. I believe Ben Eder had actually problems with his, and we will continue with watching his troubleshooting video, but I believe ours is actually working. But I'm not sure what kind of issue he has. Maybe there's an issue I don't realize that we have. So what happens now if we execute the clock? Currently it's configured in a way that this register has the input enabled, so it will read anything that is currently on the bus, and the ALU is outputting its result on the bus. So right now, so if you look here in the register itself, it's 1111, so the highest value, but on the bus it's already -1. So if we execute the clock, it will move now the value with the -1 into this register, which means the ALU will then calculate -1 from that and put that on the bus again. And with the next clock, we move that value in there. And through that, we basically circle here around and always decrement this value. So if we execute the clock by hand, we can see slowly this register counting downwards in binary. And the cool thing is, we have a clock, so we can let this run even automatically. Oh, this was quite fast. So here, you see the clock blinking here, and it's slowly decrementing. Isn't this awesome? But let me turn this off really quick again, because I have something else to show. See what arrived? It's a replacement unit. Okay, so this is the FLIR thermal camera. I had ordered one already last week, and then it arrived and then it didn't work. Now this one worked. At least it worked once. I hope it works now live on stream. If it doesn't work, I have a backup video made. Okay, so let's see. Perfect, so you can see here my phone on the screen here. Maybe, yeah. And then we can turn the FLIR on. And please work. Please work. Oh, yeah, it worked. It turned on. It's so scary because in the beginning it stays red, and then at some point it starts turning green, and so it's like a huge wait moment to wait. Ah, crap! It's already pretty warm, those chips there. Come on, cool off. Okay, so this, I guess I did the order wrong there. And then let's turn on the power again. Now you see it blinking, and you see immediately the color slightly changing. And if we just wait for like a minute or so, oh, you see the red coming up there on those bus transceiver. This one in the middle there, so this one here, this one has to run all these LEDs. So there's a lot of current flowing through that one, and so it will become quite hot. So we can, I mean, relatively. So we can see that it's like roughly 40 degrees compared to next to it like 30 degrees. 47 degrees, 45. But yeah, okay. Glad that I spent 400, no, not quite. Yeah, 400 euros for this gadget for the stream. I hope you enjoyed that. You look like Andrew Scheer. That's a first. I haven't heard that. I actually don't know Andrew Scheer. I don't know who that is. I'm usually told that I look like Michael Cera. Awesome, right? And yeah, so right now it's running super fast. As we know, the maximum frequency this currently runs at is 500 hertz. And so in 8 bits you can store up to 256 values. 250, it counts up to 255 basically. So which is roughly half of 500 hertz. And so in each clock cycle it will decrement once, which means with 500 hertz it will be able to count to 255 like twice per second basically. And this is actually kind of what you can observe. The front LED now is indicating like the highest bit, and this should turn on and off twice per second. And so if you count this, like, yeah, you should see that this LED down there is blinking twice per second roughly. Will there be a more serious version of your beauty tutorial? I mean, I like the experience. That's the main problem why I can't give you any more serious one. I mean, it's as serious as I can do it because I have no clue. Okay, I have something else for you. I have something else to show before we head into the video. Do you see that smiley face back there? See that smiley face in the back there on the table? Guess what is in there? Let's do an unboxing stream! So what do we have here? Cable. Come on, go out of here. Awesome! We have some a new pair of like, I forgot. What is the English term? I forgot. But this one has like a more pointy end with it, which is curved. So it's easier for me to like go in there and maybe bend the cable or lift the cable out. And I hope this is better because the one I had here was just like a broad one. However, giving you a product review right now, I actually really don't like the mechanism of this one. I didn't actually pay attention to this at all when I ordered it, because this one gets really close before you have the spring effect. So I really don't like that actually. I was hoping it would be the same like this one, where it would open up a lot and has the spring inside here. What a cheap out design. That's terrible. Maybe you can bend this to make it a bit more. Yeah, but nah. I might look for another one. Don't like this theory, but it should still be helpful. It should still do its job basically. So yeah, I hope this is helpful. See, I thought this is the same like line of clippers, but it apparently is not. I don't know. I just paid attention to this kind of color, so maybe there's a different even line. They have so many different like classifications and stuff. Okay, so what else do we have in here? Okay, so another thing we have here is a better multimeter. In one of the earlier streams, I failed. It was a real bad fail. I have this other multimeter here. I have this for quite a while now. It's an extremely basic multimeter, and I tried to measure a capacitor with it until I could have sworn I did it the previous day already, and so I tried to measure it, and then I couldn't measure it, and people were telling me it can't measure it, and I didn't believe them, and at some point I realized, oh, it's right, I actually cannot measure capacitance with it. So yeah, I decided to buy a differently one, and then I asked Stream, and I thought about buying like a big fluke one because I don't know, just have a professional one that will be useful for basically a long time. But then I decided to go with this one here. This one was also recommended by a viewer. It seems to do a pretty good job for in general, and should be good for like electronics work. So let's hope that this was a good purchase decision. Oh my gosh, look at that. Do the kids in chat still remember this kind of connector? Okay, does it have a battery? Will it be in the top 500 supercomputers? It might be in the bottom 500 computers. Okay, no battery in there. What does it need? A 9-volt battery? Okay, so there's no 9-volt battery included. Yeah, we are 42 minutes in and we have added 0 wires. Is that amazing? That means you will have infinite progress after the first wire. It can only get better from here. Okay, there we go. Okay, let's try this. There we go, it turns on. Okay, so now we should be able to hold that against here. And we measure 150 ohms. Sorry. 150 ohms. You could hook Arduino to the multi. Right, it does have a serial connection actually. We could totally hook that up to the computer. That might be a fun project. Maybe, I'm sure we will reach a point where we need some parts or we need to wait on something. And that could be a fun project to write some code to be able to put that on stream. That would be actually pretty cool. Also, some people would say I should also try to hook the oscilloscope on the stream as well. On the other hand, we make so good progress, so we will be soon done with this. And then I don't know what we do afterwards, because it's not like I do a lot of electronics. I don't know what we do after that. Awesome. Okay, now I have one last thing. One last thing arrived, and I hope this time it's better. Who can guess what else we have? What else is in this smiley box? Ground is common. The connection means they are sharing common ground. Okay. Fail. Whatever. Everyone from last week knows. Let's really hope this one is better than the terrible thing we had last time. A CD! Just kidding. A wire stripper! Please work for our purpose, please. Oh, please work. This one is massive. An ancient artifact. Oh my gosh. Oh my gosh. I can't believe it arrived. See this ancient technology? Bam! Beautiful. My gosh. It works! It works! Let's start with that video then.
So in the last video, we built this arithmetic logic unit. Sometimes just measuring voltages can be
Look
can
at
be really
that
helpful.
expensive
So I've
Fluke
got,
multimeter.
multimeter here, and then the probes are just these little. So
I've done the same
look at
test
our
right now,
first bit,
and it
second
looks all
bit,
good on ours.
third bit, to better understanding what's going on.
All right. Okay. So
Well, now that we've built our
we don't have the same issue, but we kind of knew this already from last stream. Yeah, I think it's so cool that now people are stumbling in here that didn't come like from my YouTube or something and have no clue what they are seeing. That is awesome, because that is kind of what I was hoping by streaming and just chatting. Look at this here. I've played around with this while we were watching the video a bit more. So I have connected here these to the clock signal right now. And so this can also measure the hertz. Last time we had to use the oscilloscope that is up here to measure the frequency of the CPU clock, but we can also measure it here. So right now it's running with 2 hertz. And so we can also increase the clock speed of the CPU, and this multimeter can also display this. So 5 hertz, 15 hertz, 122 hertz, and then we can also go all the way up to 0.5 kilohertz, so 500 hertz. That's pretty cool. Why don't you use Firefox? Why should I use Firefox? Or at least Chromium? Why should I use Chromium? There we go. We are back. This, I cannot believe how expensive this device is and how terrible it works. Absolutely awful. See, you can do like cool stuff like this. Like I can touch here, and there's my handprint. Well, the hope is that we can like see if we have like overheating components because we connected them wrong, that we would be able to see that and see them like spiking up extremely. Like right now these chips are just like 44 degrees, and this in this room is already pretty warm. So that's like perfectly fine. But if it would get up to 50, 60 or 70 degree, we would know, oh crap, this chip has a problem. And so we can use that for debugging. At least that's what I tell myself and how I justify the cost. It's like 380 euros or so. Okay, you want to see my face? Are you ready to see my face with that? Scary. The power supply there too, and up there you can see the cold air rushing in. I mean, it's not that cold, it's like, you know, not that efficient. 24 degrees is coming in there. Pretty cool toy, huh? But you can also see that, for example, the 555 chips up here, so these clock chips, they don't really get hot. It's really these ones that are driving also like these output LEDs and stuff like this. I guess that's the reason why they get hot, so hot in difference. And also it's interesting that it gets hot over there. Why does it get hot over there? So this is the it's not quite clear which cable it is that is radiating this heat. Oh yeah, no, these are the wires coming from the power supply. I guess maybe this connection, I mean, this is drawing like 0.6 ampere right now, and maybe these wires are so thin that they just do heat up a little bit. I mean, again, not massively, like they are not burning through or anything, it's just like 2 or 3 degrees hotter, but you can still clearly see that. On the other hand, these wires here are pretty, yeah. You can also adjust here, the camera alignment is a little bit off, it depends a bit on the angle and stuff. So now it's kind of there correct. You know what? When the first time I did like electronics as a teenager, I was modding my maybe I can even find the video or some pictures of it. Oh, in some YouTube video I might have even shown a short clip of that. So I modded my school's calculator. Like we got these my camera. We got these big graphing calculators in school, you know, like the bigger ones. So I cut like a window in the back so you could see the PCB of the calculator, and then put plexiglass in there. It was completely scuffed and dodged. It looked terrible. But then I put like LEDs in there and hooked it up to the battery of the calculator as well, and added a little switch. And so when it was like put down, you could turn it on, and then it had like underground lighting, like, you know, like cool cars just on a calculator. And then if you turn it over, you had like the window, and you could see like blue LEDs on the onto the PCB of the calculator. And I didn't have a soldering iron back then. I did that all with a hot glue gun. Hot glue gun, and just like drilling the wires around the legs of stuff. Did you graduate in electronics? No, I do computer science, so mainly I do software stuff. Right now, this is absolute amateur stuff I'm doing right now. I couldn't build this myself. I'm following, you know, the video series, right? I'm an amateur in electronics, but I like to learn that, you know, that's why I'm doing it. I have probably a better electronics home lab than like a server lab, but I don't really need servers or anything. Every time when I need a machine, I usually rent it from like DigitalOcean or something.
And then of course we have our clock in here as well, which is this white wire. And in this case, input and out.
Crap! We forgot to put a nice white wire underneath all the thick layers of green cables, like Ben Eater did it. Time to disassemble. We are up to negative 16 wires. Yeah, no, I'm not ripping those out. Either I put the wire over it, or I try to put it under, or I put it over it, but I won't pull out those green wires anymore. Okay, let's strip one side. Let's strip one side of this for now. You don't even understand how simple that is. It's so smooth. Okay. It's a bit curved now, just because of... Yeah, I guess here you can see the difference between a Logitech webcam and a proper DSLR. However, I did color correction on the Canon, and I don't think I did that on the Logitech. So the Canon is, you know, shooting with in a certain color preset, and then like in a, you know, same thing with this camera. I also you know, this is also a good DSLR camera, and I'm also running, you know, like a color adjustment, what's it called? Forgot the term. Yellow is the control lines. So up here, this yellow is, for example, the input enable, or here this yellow is the controlling of subtraction or addition. So yellow is like control line. Red is VCC, black is ground. Green is output of something, and blue is input. I think it was. So here, blue input is coming into these chips, and green output is coming out, and that output just happens to go somewhere else, and then that output also is not going somewhere else. This green output goes into here, and this green output goes into here, and later we will probably have different kind of colors to go onto the bus. Maybe, I don't know. Let's quickly check if it still works. We put the input enable here. The output enable here. Input. Oh, there we go. Okay, yeah, still works. The clock is arriving down there.
In the last video, we looked at the 7.
Cool. This was actually the one chip that I had to order from eBay from China, because I also couldn't, as you mentioned in the video, it's somehow difficult to find them. Yeah, so. Why would a RAM chip output the inverted value? Yeah, I don't know. Doesn't really matter. Well, then just put an inverter behind it. You know, I don't know. You know, it's just as humans that think of it kind of as inverted, I guess. You know, that a 1 is a high and a 0 is a low could also be the other way around. You know, this chip just happens to be so. It probably makes something on inside of the circuit a lot easier or cheaper or something. I don't know. But it doesn't really matter, you know. Are you ready? Oh, ASMR. The old one was better? Oh, yeah, okay. Yeah, so then maybe this one is better. Wait for it. That actually is better. Damn. Well, get used to this, because this is what you will hear more. How could I have lived without this? This is incredible. Why did nobody tell me to stop streaming until I have one? I also realized I need to change the add wire command to allow... I think it would only increment. I need to make a version where I can also just add multiples at a time. Otherwise I need to always... So we got 1, 2, 3 more. There we go. Do you have admin rights and you can just edit? Is that what you are saying? Are you hacking into my Stream Elements account to add this command? Nules is a real hacker. Pay attention. He actually can do this. I actually believe him that he can hack into my stream elements to do it. You all should be careful with him. Or her, I actually don't know. Moved wire. Why would we need moved wire? Nules has forced you to accept free labor. No, he's employed. He's right here doing very good marketing for his company. Okay, so we connect, for example, the 0 with, and this is the inverter. Do you use moved wire as a shortcut for remove wire and add wire? Oh, that's a good one. Oh, we were actually at 9 wires. Thanks, Nules. So here, this was proof that he was able to take control of my Stream Elements account and change the bot commands. And as you can tell, you saw my hands, I didn't do anything. Wasn't me. I can't get over this wire cutter. This is making me more happy than it maybe should. Like, of all I spent so much money for this whole stream. The past few days, basically every day I get some packages to just small stuff to improve my setup here. And this here is by far the one that makes me the most happy. So power's on, you can see it blinking, it's executing. And see how these chips are slowly heating up, they get like yellow. I don't think that we get excited easily. This is quite some crazy shit we are doing here, I think. Okay, yeah, so that concludes today's stream. Thanks so much for hanging out with me again. Thanks for coming back after yesterday. We have retained like 200 viewers almost consistently throughout the stream, so that's pretty amazing. Thanks for hanging out with me. Thanks for everybody who just stumbled into this Just Chatting stream, not coming from my YouTube channel or whatever, and just hung out with us nerds for a little while. I think you are awesome. That's it. Yeah, thanks. See you tomorrow. Bye-bye.